Assalamu alaikum. Today we are here to solve one of the papers of AS Computer Science, Paper 1, Theory Fundamentals of 9618, Paper 11. So let's start the paper with Allah's name, Bismillahir Rahmanir Rahim. Rabbi Shrah li sadri, wa yassir li amri, wahlul uqdatam min lisani yafqahu qawli, Rabbi zidni ilma. The duration of the paper is 1 hour 30 minutes. You have to answer on the question paper. No additional materials are needed. The instructions: you have to answer all the questions, use a black or dark blue pen. You have to write your name, center number, and candidate number in the given boxes. You have to write your answer to each question in the given space. Do not use an erasable pen or correction fluid at all. Do not write on any barcodes. You may use an AG pencil for any diagrams, graphs, or rough drawing. Calculators must not be used in the paper. The paper is of 75 marks. The number of marks for each question or part question is given in brackets. No mark will be awarded for using the brand names of software packages or hardware. Question number 1. Anya scans an image into her computer for a school project. The scanned image is a bitmapped image. Part A1. Complete the following table to describe the two terms about graphics. The first term is pixel and the second term is file header. It's a 2-mark question. So how can a student score for each term? For pixel, if he says a single square of one color, or if he says the smallest addressable element in an image, it means this is a valid answer and he will be scoring 1 out of 1. For file header, it is storing the data about the bitmap image. For example, it is going to store the number of colors. So that will again award him another mark. And in this manner, he will be scoring 2 out of 2. Part 2. The image is scanned with an image resolution of 1024 multiplied by 512 pixels and a color depth of 8 bits per pixel. Calculate an estimate for the file size, giving your answer in maybe bytes. Show your working. Now, for this, what you need to do is, first of all, you need to start with the values. The first is the value of resolution, that is 1024 by 512 pixels, and the color depth is 8 bits. So these are the values that are given to you, and you know the formula. The formula is the resolution multiplied by color depth. So this is the working area. And since the resolution is 1024 by 512, that's why that is going to come in the numerator, multiplied by 8 because of 8 bits. And since it is 8 bits, and my answer is needed in maybe bytes. So for that reason, you have to do the division, or in the denominator, the first value that you will write is 8 to convert it from bits to bytes. Then it will be multiplied by 1024 to convert it to kilobytes, and another 1024 to convert it to megabytes. Just remember the same as we have learned. In this manner, you will be through with this first stage of your answer. Now moving to one mistake which normally the students make. Since remember that we are not allowed to use a calculator, so do not go for multiplication of the values at all. Keep it simple and go for the cancellation. So here we can see 8 and 8 is going to be cancelled out. And then you are left with 1024 and 1024. This is also cancelled out. The numerator and denominator values are cancelled out. It means that then you are left with 512 in the numerator and 1024 in the denominator. And you know 512 multiplied by 2 is 1024. It means 512 times 1 is 512, and you are left with only divided by 2. It means it is 1 upon 2. And 1 upon 2 means 0.5. So here you can see in hardly a minute, just being a little cautious, we have solved the question and we have got the right answer. Instead, assume that another child is doing the mistake of doing the multiplication. So he may end up with a wrong calculation and his time is wasted. Most important is the time. And you remember the time is only 1 hour 30 minutes. So be cautious, just work smartly and score the marks. Part B. The image is compressed using lossless compression. Identify one method of lossless compression that can be used to compress the image and describe how the method will reduce the file size. It's a 3-mark question. First thing is you have to identify the lossless compression method, that is run length encoding or RLE. And you know what is the description? It is replacing the sequence of the same color or the pixels with color code and the number of identical pixels. So 2 marks are going to be awarded if you have mentioned the 2 bullet points. The first one is replacing the sequence of the same color of the pixels with color code and number of identical pixels. Now moving to the next part C. One of the colors used in the image has the hexadecimal color code, that is hash FC238A. FC is the amount of red, 23 is the amount of green, and 8A is the amount of blue in the color. Convert the hexadecimal FC into denary. Now, you have learned different methods. It's converting a hex value to its equivalent denary. So simple method is you do it in this manner, that you convert the hex value to its equivalent binary value, and then you convert the binary value to its equivalent denary value. So F is all ones, 4 bits, and C is 12, and you know 12 is 1100. And remember, it's basically the use of 4 bits or a nibble here. So now you have converted the hex value to its equivalent binary value. Now the next stage is to convert the binary to its equivalent denary, and you simply will add up all the values that have a value of 1. So 128 plus 64 plus 32 plus 16 plus 8 plus 4, and that gives you 252. In this manner, 1 mark is yours. Now, second part of part C. The amount of green in binary is 001 00011. This has the denary number 15 added to it to create a second color. Now let's have a look. It says this has the denary number 15. I didn't say 15, I say 15. Add it to it to create a second color. Add the denary number 15 to the binary number and give your answer in binary. Now, it's basically dealing with 2 stages. The first one is to convert 15 to its equivalent binary and then find out the addition result. So here the original value was 001. You can see here 001, then 3 zeros, and then double 1. Just to make it simpler, again a suggestion, you always put the values in a nibble form. That is the first nibble and this is the second nibble. In this manner, your working will be more accurate, or you can say you will be able to find out the errors in your answer also, in case, God forbid, they happen. Second is converting the denary number 15 to its equivalent binary, and that is 00001111. And you know 15 is 1, 2, 4, and 8 are turned on. Then starting from this side, 1 plus 1, 0 with the carry of 1. 1 plus 1 plus 1 is 1 with the carry of 1. 1 plus 1 is 0 with the carry of 1. And then you get 1 plus 1, 0 with the carry of 1. 1 comes here. Then 1 plus 0 is 1. 0 plus 0 is 0. And 0 plus 0 is 0. So your final answer will be 00110010. Again, you can simply, if you really want, you can do the conversion back to denary to find out that whether your answer is matching or not. Now, the third part, hexadecimal 23 in 2's complement representation is 00100011. This is 23 in 2's complement. The denary number 10 needs to be subtracted from this value. Subtract the denary number 10 from the 2's complement representation of this number. Now that the number is 001 00011. Now give your answer in binary, show your working. So first thing is we are finding out the binary for 10, and you know the binary for 10 will be 8 will be on and 2 will be on. The rest of the bits will be off. Original question was 0010 and 0011. And from that, we are subtracting the value, that is the value of 10, and that is 00001010. 1 minus 0 will be 1. 1 minus 1 will be 0. 0 minus 0 will be 0. Till this point, it's simple. Now moving to this part. 0 minus 1 is not possible. So it will borrow from its adjacent value. Now, this 0 itself is not having the value, so it will ask or request its neighbor, its adjacent value to give its number. So it means that 1 was containing a value, so it has given its number to the adjacent neighbor, making it 10, or in other words, 2. This, when given back to this one, became 1 itself, and this made it 2. Or you can say 10 or 2, both are equal. Just to make your life easy, either we say 2 or we say 10. They both mean the same because 2 is for us to understand, and 1, 0 or 10, as I'm saying right now, is something to be understood by the computer. So now it is basically 2. So 2 minus 1 is a 1. So just be cautious. With a little bit of the caution, you will be getting the answer accurately. Now earlier it was 2 or 10. It gave its 1, and it became it became a 1 itself. Instead of 2, it became a 1. So 1 minus 0 is a 1, and this was 0. It had become a 0. So 0 minus 0 is a 0. 0 minus 0 is a 0, and 0 minus 0 is a 0. By the way, there are different ways of doing it, but if you think that subtraction is one of the methods that you can do easily, again, a suggestion that do it this way. Up to you whether you want to do it this way or you want to convert it using 2's complement and then do it. That's perfectly okay, because both of these will give you the same answer. Now, there are 3 marks. It means marks will be awarded for doing the conversion of binary of 10, finding out the binary of 10, and then doing the proper subtraction. Now, the next part D. Anya made sure that the image was not subject to any copyright before scanning it. Describe what is meant by copyright. It's a 2-mark question. So it means that they want us to write 2 valid points. What is copyright? The formal and legal rights to ownership, or you can say intellectual property rights. It is going to protect against unauthorized production of the work. It will provide for legal right of redress. In this manner, writing down any of the 2 points from this will give you 2 out of 2. Question number 2. Bingwen's computer comes with an operating system and utility software. Draw one line from each utility software to its correct description. So let's see, the utility software is on the left-hand side and the descriptions are on the right-hand side. So which are the utility software that is mentioned here? Disk formatter, defragmentation, backup, and disk repair. And the definitions on the right-hand side: scans software for errors and repairs the problems, moves part of files so that each file is contiguous in memory, creates a copy of data that is no longer required, sets up a disk so it is ready to store files, scans for errors in a disk and corrects them, creates a copy of data in case the original is lost. So very quickly, just try to attempt this and let's see what is the right answer for each of the utility programs that are being mentioned here. The first one, disk formatter. Out of these, which is the right answer? Sets up a disk. Definitely scans software is not the one. Moves part of the files is not the right answer. Creates a copy of the data that is no longer required. Sets up a disk so it is ready to store files. This is the definition or the brief description of disk formatter. Now this is the correct answer. Now second one is defragmentation. So what is defragmentation? You know that defragmentation means removing the non-contiguous locations and bring the file in contiguous locations. So it means moves parts of files so that each file is contiguous in memory. It is consecutively present together in all the memory locations. So in this manner, this is the right answer for this part. Backup. Now here, backup creates a copy of data that is no longer required and creates a copy of data in case original is lost. So which one is the correct answer? Definitely no longer required is not the answer for backup. So the answer for backup will be creates a copy of data in case the original is lost. Now we are left with one, disk repair. And what is disk repair? Scans for errors in a disk and corrects them. Scanning for errors in the disk and correcting them is the definition of disk repair. So let's see, the question is of 4 marks. Being cautious, being clear that this is completely out of question. So you can see why completely out of question, because that is no longer required. That is completely wrong. So in this manner, you will be scoring 4 out of 4 just by being a little cautious in the definitions of each of the utility program. Identify 4 key management tasks that the operating system will perform. Now, what are the key tasks? Now, there are 4 marks to be awarded for writing down 4 valid points. Memory management, file management, security management, hardware management, input and output management, process management, error checking and recovery, provision of a platform for software to run properly, provision of a user interface. So out of these, any 4 points written properly in just identification, no discussion or description is needed here, you will be awarded 4 out of 4. Okay, now the next question. Question number 3. A processor has one general purpose register, the accumulator, and several special purpose registers. Part A. Complete the following description of the role of registers in the fetch execute cycle by writing the missing registers. Now, by writing the missing registers, now you can see the passage. Let's read the passage first, and then we can proceed with answering the blanks here. The blank holds the address of the next instruction to be loaded. This address is sent to a blank. The dash holds the data fetched from this address. This data is sent to the blank, and the control unit decodes the instructions opcode. The blank is incremented. Now I'm just giving you a hint. The register, whose name is supposed to be written here, is holding the address of the next instruction. So with next instruction, it is going to be only one register that hits our mind. The address is sent to from that register that we have to write in the first blank, the data is sent, or the address is sent to which other register? This is what you need to recall. The dash holds the data. Now again, the keyword is data. The data fetched from this address. This address is sent to the destination, and the control unit decodes the instructions opcode. What is incremented? Again, we know there's only one register which is incremented. So the question is now very clear to us. The program counter holds the address of the next instruction to be loaded. This address is sent to MAR, or memory address register. The memory data register holds the data. Again, this is the clear hint. Data is present in MDR, or memory data register. So that is what is going to come as the third blank. Holds the data fetched from this address. The data is sent to the CIR, or current instruction register, and the control unit decodes the instructions opcode. Now then, program counter, or PC, is incremented. In this manner, 5 marks are going to be yours. Now, question number 3, continuity, it's part B. The following table shows parts of the instruction set for a processor. The processor has one general purpose register, the accumulator, and an index register, IX. Now, these are the instructions: LDM, #N, immediate addressing, LDD, direct addressing, LDI, indirect addressing. Then we have LDX, that is for index addressing once again, and LDR, then MOV, STO, ADD, add, then INC, increase, CMP for comparison, JPE for the condition, the comparison being true, what is supposed to be done, JPN, what is supposed to be done if comparison is false, and GMP is just jumping to the given address. out for outputting the character on the screen, and then end is going to end the return the control to the operating system. LSL hash n and LSR hash n. These are the bitwise operations that we have studied. Now let's move to the question. The current contents of the main memory and selected values from the ASCII character set are given below, are shown here. Now there are addresses, as you can see here: 200, 201, 202, 203, 4, 5, 6, 7, 8, and 9. And on 209, it is the end instruction that is there. Beside this, here we can see 365 is holding 1, 366 is holding 3, 367 is holding 65, 368 is holding 66, and IX or index register is holding a 0 here. On the other end, we can see the ASCII code table. That is, only a few selected codes are mentioned here. That means A is 65, B is 66, C is 67, and D is 68. Now moving to the question. What is the question asking me to do? This is my question. Complete the trace table for the program currently in main memory. Now there are columns here. We can see instruction address, accumulator, then we have memory addresses that are 365, 366, 367, and 368. And then IX or instruction register, and the output is the last column. Now let's start solving it one by one, and then we will be Okay, now I'll be jumping back and forth between the instructions and the tables to get a very clear idea. And definitely, I expect you people to be doing the work with me just to get a very clear idea. Now, let's start. The very first thing that I need to mention is, you can see the first instruction is 200, and that says LDD 365. So very first thing that I'm doing here is I'm simply writing 200 and then moving to the LDD thing, 200 in the instruction address, because that is the instruction address that we can see here. And then it says LDD 365. Now let's move to the table and see what is LDD doing. LDD address, that addressing, load the contents of the location at the given address to ACC. So it means whatever is present at location 365 will be loaded in the ACC or accumulator. Now let's see what is at 365. And you can see LED 365 means it will be moving to 365, and the value 365 is 1. So that will be loaded in your accumulator. So here the accumulator will hold the value of 1 here. This is my very first thing that is done. Now moving to the next instruction, 201 CMP 366. Now 201, and that says CMP 366 means compare the contents of ACC with the contents of 366. CMP, compare the contents of ACC with the contents of the given address, that is 366. Now ACC is holding a 1 here and 366 is holding a 3 here. So you can see 1 and 366 is 3. It means the comparison is done, but nothing is going to happen because the comparison is not successful. So what will happen? You will simply mention 202 here. Now let me just explain it once again. After comparison is being done, you can see comparison is going to result in either both the contents to be equal or the contents are not equal. Now JPE, as we have talked about, is going to be a certain thing that is going to happen when the comparison is resulting in a true statement. And since the contents of ACC and 366 are different, that's why we will simply move to the address 202, but nothing is going to happen. Like, this instruction will not be executed as such. So there will be only the movement to the next instruction. As you can see, that will be 203. I hope that that is very clear. 202 will be written, but nothing is going to happen, and the next instruction will be 203. And this 203 says increase. INC ACC means increase the contents of ACC by 1. INC, add 1 to the contents of the register, ACC or IX. And since the question says increase, so that will be simply increasing the contents of ACC by 1, and it becomes a two here. Simple. Now, increase, add 1 to the contents of the register, which is going to be either ACC or IX. So in this case, since the instruction was increase ACC, that's why we have simply increased the contents of ACC from 1 to 2. Increase ACC. STO 365. Now, what is STO doing? STO simply means, you can see here, STO means store the contents of ACC at the given address. So whatever is present in ACC will be stored in your desired location, that is 365. So it means STO 365 means whatever is present at location 365, whatever is present at location in the ACC will be stored at 365, and it means that now it will be storing the value of 2 here. So 204 results in moving the contents of ACC to the location that is mentioned here. Now moving back to this one, move IX. Now MOV IX means now it has to do some work on IX. And what is MOV doing? MOV is here to move the contents of the accumulator to the given register IX. It means that with this instruction, the contents of ACC will be moved to IX also. So here it results in 205, and the contents of the accumulator will be moved to IX also. That will become from 0 to 2. Now, the next instruction. After MOV, the next instruction is, and remember it's instruction, LDX 365, and that is 206. 206 LDX 365, but before we do it, let's do it here. 206, and that is LDX 365. LDX 365 means it will be index addressing from address plus the contents of the index register. I'm repeating, from the address from address, the one that is mentioned in the LDX value, and the LDX operand, and plus the contents of the index register. Copy the contents of this calculated address to accumulator. So it means that we have to just move to 365. It says LDX 365. It means it will be 365 plus your IX is now holding 2. So that means 365 plus 2 is 367. And the value 367 is now holding 65. It means this instruction simply means copying the contents of this 65 to the accumulator. Okay, fine. I'm repeating. It says add the contents of 365 and the contents of IX. That makes 367 because the IX is holding 2. So 365 plus 2 is 367. And then 367 means the contents of this calculated address is 65, and that is stored in the accumulator. That is what we have done till now for the value till 206. Now let's move to the next instruction. The next instruction simply says out. No operand is there, only the opcode. And this out simply means what? Be a little cautious with this out. Output to the screen the character whose ASCII value is stored in ACC. Whose ASCII value is stored in ACC. So it means ACC is holding 65, and we know the value for 65 is A. So it means with this instruction, it will result in outputting the contents of the value in output, and that will be capital A. So this is how the value capital A will be on the screen. And then it says GMP 200. GMP 200 means it will be now jumping to, after it is done with this, it will be 208, and 208 simply says jump to 200, so it will be 200, repeating the whole process. So the same process that we have just finished here will be repeated for the second time. Now let me do it a little quickly. I hope that this explanation is clear to all of us. And now let's move to this GMP, and GMP 200 means simply jump to 200. And let's start once again. LDD 365 means what? Load the contents of 365, whatever is present at 365 in the location, and that will be your ACC will be holding 2, because the contents of now I hope in the beginning it is a bit difficult for you people, so you may move back and forth to the table so that we can be confident about the working. It says LDX. What does it say? It says LD D365, and LDD365 means direct addressing. Load the contents of the location of at the given address to ACC. LDD365 is going to be now 365 is now holding the value of 2, and that is why the value of 2 is now stored in your ACC here. After that, the same process, 201. 201 means comparing the contents with 366, and 366 is holding the value of 3. So again, the comparison is not successful. Then 202 is going to be repeated. 202 is your JPE 209. So again, the result will be not successful. Like 202 will not be executed as such because the comparison is unsuccessful. Again, the value of in 203, the value of your ACC will be increased by 1. From 2 to 3, it will become, earlier it was 2, now it will become 3. Now see, 203 is going to be increasing the value. Then it will be STO 365, so it means the value of this 3 will be stored in 365 location. At location 365, and this is your 204. 204 is storing the contents of the ACC in 365. That means the value of your accumulator 3 will be stored in 365. That is done at location because of address 204. And then 205 says what? 205 says move IX, means move the contents of the accumulator to your IX. That means the value of 3 will be moving to index register. And then 206 is going to be your LDX 365 once again. So now LDX 365 means it will be 206 LDX 365, and LDX means it will be the index addressing. Form the address from address plus the contents of the index register. Copy the contents of this calculated address to ACC. So you can see it says what? It says LDX 365. LDX 365. And LDX 365 means 365 is the address plus the contents of ACC. That makes it 368. And the contents of 368 are going to be your value 66. So that will load the value 66 into the accumulator. So your accumulator will now hold 66. Fine. I hope that this is very clear to this point, no confusions. And then after this, it is going to be the next instruction that will be out 207 means outputting the contents of 66, that is B, to the output column, and the value B is going to be here. And then what is the next stage? You can see the next stage is GMP 200, and GMP 200 means it will be again doing the same thing, repeating the same process once again. So you can see here, it will be 208 will be jump instruction. And just this jump instruction results in 200 to be done once again. Now moving to the 200. And this 200 says LDD 365 means load the contents of 365 in your accumulator. And now your accumulator is holding, what is the value that is present in your accumulator? Yes, 365. And 365 is holding what? 365 is holding the value of 3 now. So now with this one, what will happen? This 200 means the contents of your location 365 will be stored in your accumulator. So this is going to happen. And then 201. 201 is CMP 366. Now comparison of the contents of ACC with 366. And 366 is the column that we just talked about, and 366 is holding the value of 3. There's no change, as you can see, is in this column. It means that now the comparison is same. The comparison is successful. And that results in the value. Now you can see this is now the result being true. So now 202 will be CMP 366. The contents of ACC is 3 and the contents of 366 is also 3. And now the condition is true. The comparison is true. So that is why it will jump to 209, and that is going to end your program. So that means after 202, you can simply mention 209, and that is the end of your program. So this is how you will be able to score the 6 marks, and the division will be for each part. If you have handled properly, the values properly, then you will be able to score 6 out of 6 here. Just need a little bit of the understanding and a little bit of the being a little careful, and inshallah you will be able to do this question very properly. Now moving to part C. The accumulator currently contains the binary number 00110101. Write the contents of the accumulator after the processor has executed the following instruction, that is LSL #2. LSL is logical shift left. It means that LSL #2 means that we want actually the two values on the left hand side to be removed from here, and the next contents which are going to be from here will be moved to, each value will be moved two places to the left. So it means the answer will be 1 1 0 1 0 1, and the rest of the two empty spaces will be filled by zeros. Be careful. These zeros are not these two zeros that have been removed. These zeros are coming from outside, just to make it simple. These are not these zeros that have been removed from the byte. So just with this, your answer will be correct, and you will be scoring 1 out of 1. Part 2. The accumulator currently contains the binary number, and the binary number is 00110101. Identify the mathematical operation that the following instruction will perform on the contents of the accumulator. And they are asking me to write down the mathematical operation, to identify the mathematical operation with LSR 3. It means that LSR means it will be shifting to the right. And we know shifting to the right means division. And since it is division, it is going to be three places. It means it will be dividing the number by 8 and only the whole number will be there. Just remember, this process results in always giving you a whole number, not a fractional part. Question number 4. Melinda and her friends set up a peer-to-peer network between their computers to share data. Part A, describe the key features of a peer-to-peer network. It's a 2-mark question. So what are the key features? All computers are of equal status. Each computer provides access to the resources and data that they have because the data is distributed. Computers can communicate and share the resources. Each computer is responsible for its own security. Now, part B. Now, writing down any of the two points, describing any of the 2 points out of this will give you 2 out of 2 very easily. Now, part B. Describe the drawbacks to Belinda and her friends of using a peer-to-peer network. Now, here you have to describe the drawbacks. Now, what are the drawbacks? Reduced security because there is no central management, and it is only as secure as the weakest computer on the network. As each computer is at a risk from viruses or from other computers, each computer is at a risk so that anything may happen to it. And that is the first point. This is the first drawback. And another drawback is no central management of backup. Because if the data is from one computer is not backed up, it is lost to all of them. Like none of them is able to get that data. No central management of files or software means consistency may be difficult to maintain because each computer may have different software from the others. Another point, individual computers may respond slower because they are being accessed by other computers. Now, another point can be in order to share the files, etc., all the computers involved need to be switched on. So the files may not be always available. So these are the basic drawbacks. So if a child has mentioned any two, describe them properly. So the marks are going to be his. The next part C. Melinda connects her laptop to internet through her router. Tick one box in each row to identify whether the task is performed by the router or not. Now, routers receive packets from devices. Is it yes or no? It's yes, performed by router. Finds the IP address of a URL. Now, is a router doing this? Find the IP address of the URL. No, it is not. It's the job of the DNS. Directs each packet to all devices attached to it. This is not. Stores the IP and or MAC addresses of all devices attached to it. That is a yes. That is something that is performed by a router. And in this manner, 2 marks are going to be yours if you have ticked the right values in the column 1 and in column number 2. Now the next one. Melinda mainly uses the internet to watch films and play computer games. Tick one box to identify whether Melinda should connect to the router using a wired network or a wireless network, and justify your choice. Now here, it's a 3-mark question. Be very clear. 3-mark means that you have to write the proper justification. There's no mark awarded for ticking the wired or the wireless. So maybe a few students may tick wired and a few others may tick wireless. But whether they tick wired or wireless, they should be very clear about why have they chosen. Their justification should be accurate to gain the marks. Now for wired, what is the biggest advantage? Or you can say, how will I justify my answer being using a wired network? Faster communication because it's having a higher bandwidth. This is needed as she's downloading or streaming large files. Less time is wasted in waiting because there's no latency as such. The wired network is more reliable because it is a stable connection and it is less susceptible to any sort of interference or any sort of attack also. Less interference is there. There's less distortion. That is what we can see. And most important, wired network is more secure. So out of these, if I have chosen these points and I have described them properly, these are my points. I've described them properly. So it means my 3 points are going to be mine. Now, on the other hand, if a child has chosen wireless, so what are the advantages? How will he justify his choice? Freedom of movement, because you can move anywhere. You can move to different rooms, you can move to different locations also because you have a mobile device, and still you will be able to receive in the and the transmission of data will be possible. And you do not need a physical connection. I mean, you do not have to be present near to the socket because this is a wireless network. Is expanded if friends want to access the same network. As we know, less cabling is involved, less expertise is needed, making the initial setup less expensive. Now, I mean, we all know connecting to a wireless network is far easier, far faster, because we have a freedom of movement. For example, if my friend has come and she wants to connect to the wireless network, so that is very easy. But for wired, I need some expertise, I need some cabling. So just be clear, your justification should be right to give you the marks. Part D. Melinda sends emails from her webmail account, that is email account accessed through a website. Explain whether Melinda is using the internet or the www or both. It's a 3-mark question. So 1 mark is for identifying that she's using both. And then you have to mark 1 mark for each of the justification. Using internet because she is sending the data on the infrastructure. So we remember internet means the use of the infrastructure. So since she is using an interface, she is using an infrastructure. That is why she is using internet. Using www because accessing a website that is stored on a web server is operated by the webmail, and that is a part of the www. She is accessing an account, and this account means she is using her www part. So in this manner, 1 mark for identification that both are active at the moment, 1 mark for describing why internet, and 1 mark, another mark is for why www. Question number 5. Kiara has a washing machine and a refrigerator. She has an embedded system in her washing machine. Describe what is meant by an embedded system using the washing machine as an example. It's a 2-mark question. So first thing is microprocessor or microcontroller within a larger system is present, and that is there to perform one specific task. For example, here the embedded system in the washing machine is only controlling the program for the washing cycle, and it is a part of the washing machine, but does not perform any other function in it. It's designed to perform one specific task of washing the clothes only. Part B. The washing machine's embedded system makes use of both ROM, ROM, read-only memory, and RAM, random access memory. State the purpose of RAM and ROM within the washing machine's embedded system. Now, this is so simple. I mean, we know RAM means it is storing the data temporarily because it is a volatile memory. So what is stored in the washing machine's RAM? It is storing the choices, or it is storing the washing program that the user has entered. It is storing the data that is read from the sensors, or it is storing the time left in the program. So out of these points, a child has written any of these, he will be able to score the marks. And in ROM is storing the startup instructions or the booting instructions for the washing cycles. In this manner, 2 out of 2 are yours. Part C. The temperature in her refrigerator must be kept between 4 and 6 degrees Celsius. The microprocessor in the refrigerator turns on the cooling if the temperature is too high and turns off the cooling if the temperature is too low. Explain why the system in the refrigerator is a control and not a monitoring system. So here we can see control means, we recall, control means taking some corrective action, or in other words, it uses the feedback. So it's a 2-mark question, and if the user if the user has the user knows that you are actually taking some action, or something has happened. So the system is using feedback. The system causes the temperature to change as it is resulting in some action that is being performed, and that is why the refrigerator is a controlling application and not a monitoring system. Question number 6. Each of the following algorithms performs data validation. State the type of validation check that each of the algorithms performs. First part, input x. If x is less than 0 or x is greater than 10, then output invalid, and if. Now you can see it's simply range check. We are simply talking about the range. And its range, two values mentioned, x is less than 0 or x is above 10, then output invalid. Part B. Input x, if x equals to quotations open, quotations close, then output invalid, and if that is the presence check. Part C, input x, if not x equals to red, or x equals to yellow, or x equals to blue, then output invalid, and if that is existence check. 1 mark for each of the identification, and you will be able to score the marks. Question number 7. Bobby and Kim are discussing the databases. Part A, Bobby tells Kim that a file-based approach is usually better than a relational database. Explain why Bobby is incorrect. Why is his statement not correct? Now let's see. This is a comparison between file-based approach and the database and the relational database model. First thing, flat file has more data redundancy because the same data is stored many times. Or the data is stored in different tables which are linked with each other, and that is resulting in data being redundant or data being same, stored many times. This is the first reason that why the flat file is not a good choice. Second one, there is program data dependence with flat files means that because any changes to the structure of the data means the programs that access the data have to be rewritten. If you have used the flat file and you have made any amendments in the structure, so the data is affected. So you need to rewrite the program. But on the other hand, a relational model is completely not dependent in such a situation, and that is why it is a better choice. Another point, flat file has more data inconsistency as it's not resulting in data being like having integrity, because the duplication of data might be stored differently, because when data is updated in one place, it is not updated at each of the locations. It is not easy to perform complex searches, or queries are difficult to be handled because a new program is to be written each time whenever you want to handle a query in a flat file approach. While with the relational model, the things or querying or performing the searching is much easier as compared to the flat file. Next one is flat files could have a lack of privacy, as user views cannot easily be implemented. But when you talk about the relational model, the relational database model, there are different views that are created for different levels of people, and that helps in having more control on data availability to different levels of people. In this manner, very rightly mentioning the points, you will be able to score 3 out of 3 when you have explained, written the keywords and explained the keywords, and you will be able to score 3 out of 3. Part B. Bobby has a shop that sells products to customers. His database will store data about his customers, their payment details, orders, and the products he sells. Customers will have login details to access their accounts. The database will update customers' payments and login details without keeping any historical records. Give one example of each of the following relationships from Bobby's database. One-to-one can be customer to payment. That is one-to-one, one customer and one details. Or it can be customer to login details. Like I'm the customer, so my login details are going to be related to me only. The example from this This question is going to be one example from one-to-one is customer to payment or customer to login. One to many. So a customer can place many orders. Like me, I can place many orders. Many to many, order to product, or customer to product. So if any of this is mentioned properly, it means that he will be able to score 3 out of 3. Tick one box to identify the relationship that cannot be directly implemented in a normalized relational database. One to many, or many to many. So you can see one relationship that cannot be directly implemented. Now, if you recall, we need a link table in between. So that is many to many. And that is a 1-mark question. Bobby wants to name his database shop orders. Write a DDL or data definition language statement to define a new database with the name shop orders. 1-mark question. Create database and database name. This is the syntax that we know. So create database and shop orders semicolon means my answer will be correct and I'll be scoring 1 out of 1. Part C. A database has a data dictionary. Give 3 items that are stored in a data dictionary. So items are table name, field names or attributes, data types, type of validation, primary key, foreign key, relationships. So any of these 3 mentioned properly will result in you scoring 3 out of 3. Now moving to the another question, and that is your question number 8. And this question number 8 is, tick one box in each row to identify the logic gate that each statement describes. Now, statements are output is 1 only when both inputs are 1. Is it AND, NAND, NOR, XOR, or OR? Now just see, the output is 1 only when both inputs are 1. So which is the right answer? This is the AND gate. Output is 1 only when both inputs are 1. Output is 1 only when both inputs are different. When both inputs are different. 1, 0 or 0, 1. So that is your XOR. And lastly, the output is 1 only when both inputs are zeros. Only once. So that is your NOR gate, not OR gate. So for this, again, a suggestion, you better write the truth tables of all the gates so that your answer becomes a little, can say, you are confident about your answer. So NOR is the one, like if you remember, OR is, the result is 0, 1, 1, 1. And when you talk about this one, the answer will be, for NOR will be 1, 0, 0, 0. So that is why the output is 1 only when both inputs are 0. That is the answer for NOR. In this manner, done properly, you will be able to score 3 out of 3 here. Jazakallah khain kasira for being a part of the learning journey. Hope that you have liked the video and stay tuned. Do not forget to click on the bell icon so that you are getting the latest updates of all the new videos that are uploaded. And do not forget to comment in the comment sections so that I'll be able to know which other topic videos you want us to make the videos on. Take very good care of yourselves and your loved ones. Allah Hafiz. May Allah bless you. May Allah help you. May Allah give you a lot.